missed it here. So actually, the question is like this, no? I think everyone knows. So this is a T code 0. The source is here. Observer detector is here. A T code 0, the source is here. Then after, so by the time source reaches here, the detector will detect signal. So therefore in 20 seconds, so it will end up, it will be somewhere here at this particular thing. Okay, now what we have to calculate is like when the signal would have been generated, the signal would have been generated when it is somewhere here. And in what direction? So that it should be received by detector. So therefore, what shall we take, the red color line or the left green color line? When the detector is somewhere here, the signal would have been generated. By the time detector source reaches here, the signal will be received here. So this particular source, what when it will generate waves in all direction. I think yesterday some which particular wave will be received by the detector. Okay, I am. It's a simple idea. It is this one. No, green color wave or the red color wave will be detected by detector when it is at 2. The green color wave. So this is, I think the diagram, the red color wave will not be detected. The wave, for your understanding purpose, I'm just putting in this way here. So therefore, what can be this particular, this is V naught. So further you extend this line. This is really very good concept. It is. Okay, this should be the theta. No. So what is the velocity of detector? You have to write it. It should be V naught cos of 90 minus theta 1 or this should be theta 1. So along that green color line, please understand it's a very basic concept. I don't know yesterday why I went wrong here. No, component of velocity of detector when it is receiving along the line joining the source and detector. But the source is somewhere here. So why can't you write V naught? That is wrong. It should be V naught sine theta 1. Now you check it, you'll get answer. Able to understand? The detector will not receive the red color. So in fact, it will send waves in all direction. Don't think that only this, in all direction. So which particular wave it will receive? The one, in fact, we'll do one thing. One wave will go also like this. Nothing wrong, no? In several directions, it will send a wave. So which particular wave will be received? The green color will be received by detector at position 2. So therefore, V naught sine theta should come into picture. Okay, after this, I think we have any other, this mass, okay, no?
Sir,
Okay, yeah.
Pythagoras theorem, we are not getting T1, sir.
Good, sir.
Okay, this is T1, okay, fine. What is there? The time at which signal generate, this you have to calculate from here, no?
Get 19 seconds, 19 points.
T1, okay, I didn't. 19 second. Yeah. Okay, fine. So this is one correction. Sorry for yesterday's wrong idea. This should be because if I not corrected here, so totally will be, I would have given a wrong idea. So even
19.09.
19.0, 19.9, 1 0 9. No? So please, okay, this is a very important observation. I think here is what we have missed it. I thought I wrote it, but later on I checked it. I didn't write this theta one. So now if their source and detector are along same line, I think these angles will not play any role. But when the source and detector not moving along same line, no. So the direction in which the wave is approaching detector, velocity of detector along that particular direction of wave, that velocity should be substituted here in the numerator. In the denominator, again, what is the condition? This theta 1, I think this triangle is calculated, this theta 1 is calculated with respect to this triangle, not with respect to this red color one. Okay, this theta 1. Okay, no, so I think I made all the conditions clearly, you know. The red color triangle